Hi, I'm Dr. Danielle Fraser. I am a research scientist and head of paleobiology at the Canadian Museum of Nature. I study mammal evolution and ecology in the past and today to understand the origins of modern mammal communities. I'm excited to have been part of a team that described a new species of rhinoceros from Canada's high Arctic. The new Arctic rhino lived around 23 million years ago in Canada's Arctic and is the northernmost rhinoceros ever found. It belongs to a new species, Epiacerotherium ichiluk, which is related to species that lived in Europe and Asia several million years earlier. Epiacerotherium ichiluk was relatively small and slight, similar in size to the modern Indian rhinoceros, but lacked a horn. Today, there are only 5 species of rhinoceros, including those most people think of, such as the two-horned black rhinoceros from Africa. But the history of rhinocerotids dates back to about 40 million years ago. There were more than 50 species known from the fossil record. Rhinocerotids of the past came in a variety of shapes and sizes, from large and hippo-like to relatively small and hornless. Though limited to Africa and Asia today, they were also found in Europe and North America in the past. What's remarkable about the Arctic rhino is that the fossil bones are in excellent condition. They are three-dimensional and have only been partially replaced by minerals. The specimen is also exceptional in that about 80% of the skeleton was discovered, which is incredibly complete for a fossil. My colleague, Marissa Gilbert, was part of the team that discovered and collected remains of the Arctic rhino.
Hi, my name is Marissa Gilbert, paleobiologist at the Canadian Museum of Nature. Our team had the honor of naming the Arctic rhinoceros. Based on anatomical comparison, we know the rhino is a member of the existing genus, Epiacerotherium, but it is different enough to warrant a new species name. Because the rhino lived in the high Arctic and was found on traditional Inuit territory, we consulted with elders in the community of Grise Fiord, highest latitude community in Canada. We worked specifically with the former mayor of Grise Fiord, Jarlu Kijuktak, who had also been on our earlier expeditions to the Devon Island. We shared information on characteristics of the rhino with Jarlu and came to a consensus, choosing Ichiluk, which is an Inuktitut word that translates to frost or frosty.
To determine if the Arctic rhino was a new species, our team made anatomical comparisons to other known species of rhinocerotid. Fortunately, we have the most diagnostic parts of the Arctic rhino body, including the upper and lower teeth and other parts of the skull. We also constructed an evolutionary tree of about 50 species of rhinocerotid to understand the place of Epiacerotherium ichiluk in the grander scheme of rhinoceros evolution. The analysis showed that the Arctic rhino is most closely related to European species in the same genus, diverging between 34 and 40 million years ago during the late Eocene epoch. The Arctic rhino therefore likely represents the result of a migration event over the North Atlantic, directly between Europe and the Canadian Arctic. The Bering Land Bridge, which connected East Asia and North America, is well known for its role in human and animal migration. But many millions of years ago, animals and plants migrated directly between Europe and North America over land bridges formed between the Canadian Arctic, Greenland, Iceland, and Europe. These land bridges are not often thought of as important migration routes after the early Eocene, about 56 million years ago. But the discovery of Epiacerotherium ichiluk and our reconstructions of evolution show that the North Atlantic played a much more important role in their evolution than previously thought.